Let's look at an example where we're going to determine the points on a curve or on a graph, in this case f of x equals -1 over x, at which the tangent lines to the curve are parallel to y equals 2x plus 1. And once we find those points at which the tangent lines will be parallel to y equals 2x plus 4, we're going to go ahead and write the equations of those lines. Now, a quick reminder that the equation of a tangent line to a curve, y equals f prime at x naught, so that's our slope of the tangent line, times x minus x naught plus y naught. So the first thing we need to do is find the derivative of this function, and then with that derivative find x values that will create parallel lines to this y equals 2x plus 4. So the function that we're given is f of x equals -1 over x, which I can rewrite as negative x to the -1 power. And in this form, I can then use the power rule to find its derivative. So that implies that f prime of x will be negative, and then our power rule would be -1 x to the -1 minus 1. The opposite of a negative, or negative of a negative, is positive, so this will be positive x to the -2, or 1 over x squared. Now, what we want to do is find where this derivative, or where this slope, equals 2. So now we want to find values x naught such that f prime of x naught equals 2. And that will then identify the x coordinates where the slope of the tangent line is in fact parallel to this line, y equals 2x plus 4. So we have 1 over x naught squared equals 2. We're going to go ahead and take the reciprocal of both sides. So 1 over x naught equals 2 is the same as x naught over 1 equal to 1/2. So if I take the reciprocal of both sides of that equation, they should remain equal. Oh, and there should be a squared here. Okay, so what do we have here? We have that x naught squared should equal 1/2. So now, if we take the square root of both sides of that equation, we end up with x naught equaling plus or minus the square root of 1/2, which is equal to plus or minus the square root of 1 over the square root of 2, which is equal to plus or minus 1 over the square root of 2. So we have two x values. One of them is positive 1 over square root of 2, and the other one is negative 1 over square root of 2. So to write the equation of my tangent line, what did I need? I needed the x value. I know that now, and I use it in two different places. And I needed the y value that goes with that x value. So for each of these x naughts, we need to find the derivative at x naught, and we need to find the y value at x naught. So let's go ahead and start with x equals positive 1 over square root of 2. So if that's the case, then f at x naught would be -1 over 1 over the square root of 2. Multiplying by the reciprocal of the denominator, I would have negative 1 times square root of 2 over 1. So f of x naught is my negative square root of 2. And this f of x naught is also known as the corresponding y value. Okay, so I have an ordered pair. I have an ordered pair that is 1 over square root of 2, negative square root of 2. So I've got one coordinate pair, got an x value of 1 over square root of 2, and a corresponding y value of negative square root of 2. And now I need the slope of the tangent line at that point to be able to write the equation of that tangent line. So now we need to find f prime at 1 over square root of 2. Recall f prime was 1 over x squared. So f prime at 1 over square root of 2 will be 1 over square root of 2 squared, which is 1 over 1/2. If I square the numerator 1, I get 1. And if I square the denominator square root of 2, I square that, I get 2. Multiplying by the reciprocal of the denominator, I get 1 times 2 over 1. So I get that the slope of the tangent line there is 2. Now this is important because this was a double check to make sure that we were correct. For this line that I'm going to write the equation of, to have a slope of 2, I could have just blindly assumed it was 2 and assumed that I did all of this algebra correctly versus double checking my work and finding out that yes, in fact I did. I got the slope of 2 that I was looking for. So our slope there is 2, which is good. And let's go ahead and repeat this process for our second point. And our second x value is negative 1 over square root of 2. So similar process. We want to find the y value, so we need to evaluate our function at negative 1 over square root of 2, which is going to be negative 1 over square root of 2. So a negative over a negative is a positive, so this will be positive. And then I'm going to multiply by the reciprocal of the denominator. So 1 times square root of 2 over 1 gives me my corresponding y value that I'm interested in as being positive square root of 2. So the other point I'm interested in is negative 1 over square root of 2, comma, positive square root of 2. Now, we could assume that I did the work correctly, but let's go ahead and check. If I've done everything correctly, we should find that f prime at negative 1 over square root of 2 is in fact 2. So f prime at negative 1 over square root of 2 is going to be 1 over negative 1 over square root of 2 squared, which is going to be 1 over, now when I square this negative 1 over square root of 2, it becomes positive. The numerator is a 1, and the denominator, when I square square root of 2, I get 2. Then multiplying by the reciprocal of the denominator, I end up with a slope of 2 as intended. So f prime at negative 1 over square root of 2 is in fact 2. So now all that's left for us to do is write the lines, the equations of these parallel lines. So y equals slope of the tangent line, so that's my derivative at the point, so 2 times x minus my known x value, in this case 1 over square root of 2, plus my known y value. So plus a negative square root of 2. And that's a perfectly fine answer. Our second tangent line, so y equals, again, the slope of the tangent line is our derivative at negative 1 over square root of 2. So that's 2 times x minus my known x value, so negative 1 over square root of 2, plus my known y value, square root of 2. And again, you can go ahead and multiply that out. There's really no need to. Those are perfectly fine answers. I hope this helps.